In this presentation, we're going to look at continuous random variables and evaluating things like the expected value and so on. So in this case, we'll start off with a simple one. The random variable x has probability density function of f of x. Now you notice that we have small f there for probability density function equals k times 1 minus x times 1 plus x. That's actually the difference of squares there, 1 minus x squared. And importantly, the range of values for x is between 0 and 1. Okay. So here k is a positive constant. Okay, that will be helpful for deducing what we are trying to do. Show that k is equal to 1.5. That's the first question. And then hence or otherwise calculate the probability of x being greater than 0.25. So part A, show that k is equal to 1.5. So let's start off with the probability density function, and when we integrate the probability density function, that will give us an area under the curve. Now the upper and lower limits are 0 and 1, so when we integrate from 0 to 1, the PDF, that will give us the total area. Now the total area, we are told, is equal to 1 because this is the range of values for x, so all of the curve, all of the density function must be between that, and that means it must have an area of 1. Okay, so this is the central premise of how to calculate these questions here, that the between the upper and lower limits, that the integral of the PDF f of x is equal to 1. Okay, so let's express the PDF as 1 minus x squared, just simplifying what the expression that we were given previously, which was 1 minus x times 1 plus x. So here we have 1 minus x squared, k times 1 minus x squared. Okay, we can bring k out of it and just sort of disregard it there, just put it before the integral, just treat it as a constant. And so essentially what we're going to do here is a very straightforward definite integral. So we have the integral of 1 dx, okay, and that just becomes x, and x squared becomes x cubed over 3. And it's a definite integral between 1 and 0, and if we evaluate both of those at 0, those terms there at 0, we get 0, so we can just disregard it and evaluate it at 1. So 1x evaluated at 1 gives us 1, and x cubed over 3, when we evaluate that at x equal to 1, we get 1/3. So we have 1 minus 1/3. And remember, we're pre-multiplying this by k. So k times, this is actually k times 2/3 is equal to 1. So when you work that out, k necessarily equals 3 over 2, or 1.5, which is what we were asked. So that's it. Now, so essentially the key part is this here. So this is the bit you have to remember, and you have to sort of remember the significance of these terms here, these expressions here for the upper and lower limit. Okay, so the second question is sort of fairly similar, really. Essentially what we have to do here is find the probability of x being greater than 0.25. This is actually part B. So part B. So essentially what x is greater than 0.25. This means between 0.25 and, remember, the upper limit is 1. Okay, so it's a very similar question to what we've done before. Essentially what we're doing here is we're taking note of these new limits for our definite integral. Essentially what we're doing here is still evaluating an area under a curve, but we are using different limits for the upper and lower bound for the definite integral. Other than that, it's almost the exact same question. In fact, we're using some of the exact same calculations here. So 1.5, essentially I'm going to do it the same way. I'm going to take 1.5 out of it and just leave it to the start. Okay, just like I did the last time. So 1.5, just bring it out and only use it at the end. 1 minus x squared, when we evaluate that, we get x minus x cubed over 3. And now we're doing the same sort of calculation, but essentially the upper bound is still 1, and this is what we got before, 2/3. But the lower bound is 0.25, So essentially we have to spend a little bit of time working that out there. A little bit of calculator work, but just be very careful with it, okay? 0.25 minus 0.25 cubed over 3. Just take a moment to get it right, okay? So that's all. It's just a bit of number crunching, just to make sure you have it right. So 1.5 times the difference of those two, 0.666, which is 2/3, minus 0.244. Working that out, let's scroll down a bit. We would get 1.5 times 0.422, and working that out in the calculator, our answer should be 0.633. Okay, so you can do this a different way. Essentially, it's a definite integral, so you can sort of do different steps. Whoops, get rid of that. So, but ultimately, you have to sort of remember the significance of the upper and lower bound and the whole point of the PDF. To integrate it, you get the area under the curve, which gives you the probabilities. So that's it. We'll leave it there. Thank you very much.